welcome back to the second video of weather of Earth's atmosphere. In the first video, we talked about air masses and how they're classified based on two characteristics. The first being the moisture content of the air mass, and the second being where the air mass originated from. So, what we didn't talk about in section 1 is that these air masses can move in the atmosphere from one area to another and even collide with different air masses. That's what we're going to talk about in this video. So, when an air mass moves from one area to another, it brings those conditions to that area. And this is a movement called a front. So a front is basically just bringing unique characteristics of an air mass from one area to another. Alright, so there are five basic fronts that we are going to talk about today. The first of which is a cold front. Now, on a weather map, a cold front is represented by a blue line with blue triangles. You can probably conclude that a cold front brings cold air to an area, and it comes from a region that has cold air, such as the polar region or the Arctic region. So when a cold front moves through an area, it brings cooler than normal temperatures. Now the moisture content depends where this air mass came from. If it contains high moisture content, it came from a marine environment, and if it contained a low moisture content, it came from a continental environment. The second type of front we're going to talk about is the warm front. The warm front is represented on the weather map by a red line with red semicircles. Now when a warm front moves through an area, it brings warmer than normal temperatures. Once again, the moisture content of this warm front is dependent upon where the air mass originated from. If it originated in a moist environment, it's going to be a marine air mass. If it does not contain much moisture or contains low moisture, it is going to be a continental air mass. So those are the two key ones that I want you to remember. The third one looks like a combination of a cold and a warm front, and it's represented by alternating blue triangles and red semicircles. This type of front is called a stationary phase, and in a stationary phase, neither the warm front or cold front dominates. So there's not a whole lot of movement of different air in here. The cold front is not bringing its dominant features, and neither is the warm front in a stationary front. The fourth stage that we're going to talk about is an occluded front, and it's represented on a weather map by a purple line with alternating purple triangles and semicircles. Okay, and what an occluded front represents is that the cold front is starting to take over or dominate over that warm front. Now, a occluded front has similar conditions that a cold front brings about. The fifth and final front that we're going to talk about is called a dry line front. Now, a dry line front is unique because it only occurs in the plain region of the United States. On a weather map, a dry line front is represented by a yellow line with yellow semicircles. Now these semicircles are a little bit closer and a little bit smaller than that of the warm front, and they are yellow. So what is a dry line front? A dry line front is just a front that prevents moisture from getting into the area. So let's think the plain region of the United States. It's Texas, it's Oklahoma, and Kansas. And typically they have hot, dry summers. Well, why do they have hot, dry summers? Well, it can be explained by the dry line front. The dry line front prevents moisture from getting into those areas. So that's what creates those dry conditions. Now, we talked about the five basic fronts that we see here in North America. We're now going to shift our focus and talk about how these fronts typically develop and move across the United States. Fronts typically develop and move throughout the United States in a condition called the mid-latitude cyclone. The mid-latitude cyclone is a 5-stage cycle that develops fronts that moves in a west to east pattern and rotates around a low pressure system. So the first stage of the mid-latitude cyclone is the stationary phase. Now that might sound familiar, and it should, because all a stationary phase is a stationary front. So remember, no front is dominating here in this position. The air is kind of, it doesn't have dominant features from either of these fronts. So the movement hasn't really started yet. Now, the second stage, or the wave stage of the mid-latitude cyclone, is when movement starts to occur. The wave stage on a weather map looks like this. It has has the cold front on the left side and the warm front on the right side. And what's unique about the wave stage is that a low pressure system sits in, and the mid-latitude cyclone starts to move in a counterclockwise pattern. Okay? So the mid-latitude cyclone continues to move in this counterclockwise motion, and the warm front doesn't move as fast as the cold front. The cold front moves a lot faster. So that brings us to our third stage of the mid-latitude cyclone. Okay, and that is the open stage. Remember, the cold front is moving a little bit faster here, so it's gotten a little bit further than the warm front is. Now in the open stage, you still have that low pressure attached here, and the cold front is beginning to catch up or get closer to the warm front. Now, this is a very important stage that we will look into more in section 3 because it helps determine what weather you're having for your area. And we'll hit on that in section 3. So, the mid-latitude cyclone continues to spin and move in a counterclockwise pattern. Remember, all this time, this mid-latitude cyclone is moving in a west to east pattern across the United States. All right, so as the cold front gets closer to the warm front, we enter the fourth stage of the mid-latitude cyclone. The fourth stage of the mid-latitude cyclone is called the occluded front. And in an occluded front, occluded stage, you start to develop an occluded front. So the occluded front develops up here by the low pressure. And remember, the occluded front is a purple line with purple triangles and semicircles. Now you still have the cold front that's dominant here, and you still have a little bit of that warm front left. Now as the stage continues to develop, the occluded front or the cold front completely overtakes the warm front. And the only thing you have left in the fifth and final stage, or the dissipation stage, is a cold front or a occluded front. Either one would be the fifth stage or the dissipation stage. So this section, we've talked about how air masses move and what happens to an area's weather when an air mass is moved from one area to another. We've also talked about how fronts develop and move throughout an area. I hope you have enjoyed this section and join us again for section 3 as we become closer to predicting the weather of an area.